Aquatic Sensors services all of North America for cutting edge water quality, environmental monitoring type solutions. And we are very happy to have Obscape as one of our partners. They bring in a wealth of different solutions for different types of problem solving for anything from environmental, climate change, helping your risk mitigation. So they make power telemetry modules in all kinds of form factors with built-in sensors. They make your sensors come to life, and they just help, with your risk assessment and environmental monitoring programs overall. So we love working with them. Today, Jason Van Plexen is going to be giving us our presentation and a demo of the PTM module and the data portal. And we'll be taking questions. I'll hand it over to him in 2 minutes and well, shorter than 2 minutes, but in about 30 minutes, 35 minutes, we're going to do our presentation demo and then we'll hit a Q&A. But if you have any questions, feel free to put them in chat. And then if you have something burning, feel free to raise your hand and come on and ask. So Jason, without further ado, I'm going to pass the baton over to you. And if you want to introduce your fun and fabulous team, that would be great.
Perfect. Thank you, Andrea, and thank you, Patrick, from Aquatic Sensors. Yeah, great partners of Obscape products in Canada and the US. So, yeah, we're very proud to be here, and I hope we can add some value to you guys. I'd like to introduce our team. Paul Groves, my fellow commercial manager, and Bronwyn Goebel, Dr. Bronwyn Goebel, should I say, our strategic marketing manager. So, yeah, we are the team here from Obscape. Currently calling you in from our production site in South Africa. We have our head office in Delft in Holland. And yeah, I'm hoping to shed some of our experiences on forecasting and real-time monitoring for early warning systems. So yeah, Andrea, can I crack on?
Carry on, Jason. Carry on.
Super. Cool. Perfect. So how Obscape was born. How did Obscape come about? I just want to give you a quick little background. Our passion is obviously to bring your environmental data to life, and it was born out of the need to provide instrumentation for the toughest conditions. There was obviously a task to monitor environmental data, and we found that there was large barriers to entry in a limited amount of products that could service and provide the solution that we required. So Obscape was born out of a need to have autonomous data loggers and sensors that could be used out in the remote conditions of Southern Africa. And they needed to be inconspicuous because anything that looked like it had some value to it would go missing. And we needed to make sure that these devices could blend into the surroundings and be as inconspicuous as possible. A lot of devices required subscription fees, so you'd pay for the device and had to subscribe to a data portal or to have your data available. And yeah, we believe that your device is your data. So I will do a little presentation at the end of my slides on our data portal just to show you how it works. Your device, the data portal is included for the lifetime of your device, and that's how we've tried to do things here at Obscape. So today I'm going to speak to you about a few of the mainly environmental governance, but these are a few of the applications in which we find ourselves prevalent in as our Obscape products: offshore operations, science and research, and renewable energies. So environmental governance is really what we're going to talk to you about today. And a few of our American clients are the University of Rhode Island, University of Maine, University of North Carolina, and the University of South Carolina, and MTU. We also have a aerospace customer situated out of Texas. So many American customers have enjoyed our products, and we hope to solve many more problems in the US. So talking about early warning systems, and extreme weather events seem to be becoming more and more prevalent. Climate change does seem to be affecting the way things happen and the frequency of events. We're going to speak about 5 of those main events in this session and how can we provide more information to make better decisions regarding risk mitigation and disaster prevention? We're going to talk about flooding, severe storms, storm surge, pollution, and wildfires. 90% of natural disasters in the United States involve flooding in one way, shape, or form. So when it comes to flooding, there's two devices that provide crucial information into an early warning system or into forecasting systems. These are a water level gauge and a flow gauge. So this data, having the data is one part of the system. It is what you do with the data and how it is applied that creates the value. How can we mitigate high risk environments and how can we reduce loss? So when it comes to the level gauge and the flow gauge, there's two types. There's two main types: a radar type and a pressure sensor. The radar is non-contact, and the pressure sensor they each have their different merits. So for different applications, they each shine out. The key advantage of the Obscape solution is that plug in your solution, install your device, leave it, it runs autonomously, it looks very inconspicuous, and it will provide you with the necessary data once set up correctly. The next device that we have is a water flow gauge, crucial for hydrographic installations and for hydrological calculations, but also for early warning. Volumetric flow calculations are super important to understand what is the volume of water that will be entering a system or an ecosystem. It's slightly more complex to set up a device like this, but once you've put in the environmental inputs, looking at water profile size, water level, and once you've got that, you can calculate the fluid area, and with the fluid area inputted, you can calculate the flow rate, the volumetric flow. This is a crucial parameter. This is a crucial system for understanding or providing inputs into these early warning systems and these flow calculations, especially during flood periods. Having that information during high flood events and for flooding periods is crucial. Cool. So severe storms, quite a broad topic, but I'm going to break it down into smaller pieces. When it comes to severe storms, having a weather station and a rain gauge available, they complement satellite weather forecasts. So I think that's also another crucial aspect that needs to be reiterated during this presentation is having long-term forecasts and satellite inputs is only 50% of the equation. Localized data improves accuracy of forecasting and the accuracy of weather events by more than 50%. So how do we measure these storms and how do we track their effects? So we combine the flow gauge and the level gauge with the weather station and the rain gauge, and it provides data from outlying areas. So before they reach sensitive or vulnerable areas, these devices will be able to provide you with near real-time weather data as well as rainfall data. They also provide crucial inputs into hydrological calculations, being able to determine catchment volumes and wind parameters. One of the huge advantages of having a remote weather station is especially if it needs to be in outlying areas, the need for power or communication is not required when it comes to our devices. They work completely remotely. When it comes to a weather station, we have an onshore version and an offshore version. The offshore version is a lot more complicated than the onshore version, having to compensate for the movement of the flotation device. So having built-in GPS units and 3-axis solid-state compass, as well as a 3-axis gyro unit and a 3-axis accelerometer, they provide accurate it compensates and calculates accurate weather readings in the harshest sea conditions. Our onshore weather station is a 12-in-1 weather measurement facility, providing an array of weather parameters. And if there's a requirement for sub-zero conditions, we have a heated rain bucket which is able to calculate snowfall intensity. The simple and humble rain gauge, providing crucial value into catchment data, being able to understand areas, especially in mountainous areas. It provides detailed inputs for localized data. We normally apply these into higher areas, higher altitude areas that we can then input into the system to be able to advise on catchment and to mitigate downstream disasters. Perfect. The next is storm surge. So what is a storm surge and how does it affect coastal areas? Storm surge is the rising of the sea as a result of strong winds and atmospheric pressure changes. Obviously, during storm periods, how do we want to measure the effects of this? And that's by having outlying stations in the ocean. We use a wave buoy and identifying the effect of the storm on the coastal region by using a wave gauge. So this is a holistic ecosystem of devices that will provide information and inputs into a system that can then calculate data during extreme weather events, or used in forecasting models to predict and prevent excessive damage. So in the Obscape portfolio, we have 2 wave buoys. They are designed for different purposes and different uses. OBS 400 range, which is our smaller buoy, is used for areas where solar irradiance is limited. So solar panel buoys are going to struggle to provide enough power for communication and measurement, and hence the OBS 400 was born. It relies on cellular communication and is used for, it's had much experience in polar regions and in the North Sea. The OBS 7 watt is designed for applications where there's ample solar radiance and for longer deployment periods. Having its own power source and power supply, it is able to communicate via satellite and in more remote areas, but it does require areas with high solar radiance. Being battery powered on the OBS 400, a deployment period of up to 12 months, and depending on the level of transmission and the frequency of transmission that you require. So the wave gauge. The wave gauge is basically a radar level gauge that is able to, it has a high frequency rate, and it will provide you with wave parameters except for wave direction. This can come in a radar form or a pressure form, and it has been used by customers such as Eco Wave Power to determine safety thresholds when wave periods become too severe and the system needs to be placed into safe mode. So yeah, companies like Eco Wave Power have found benefit with a device like this for a shore-based application. So normally a crippling after effect of a disaster is the lack of power and potable water. So a hot topic even in normal conditions is water quality, and with water resources becoming more and more scarce, the need for water quality or remote water quality monitoring is becoming more and more needed. So in many countries, there are litter booms, which will prevent stick waste or other waste from entering the sea. And there's also a need to talk about the actual quality of the water if it is needed for drinking purposes. So I'm going to now chat to you about our portable or our remote water quality station and our time-lapse cameras. Integrating one of 3 water quality sondes to either look at turbidity or all of these parameters, conductivity, and you can read the rest. We can do up to six sensors at a time. This provides you with remote sensing and a good litmus test to be able to determine if there is need for additional testing. It can be used in saltwater or freshwater applications, and it can be applied onto a 7-watt buoy platform. Also on the 7-watt buoy platform, we are able to include an ADCP or a current measuring device. So if we need to determine current flows, that's also possible on the 7-watt platform. So this can be attached to the power and telemetry module as well as on a buoy platform. So last one that I think is quite prevalent in drier climates. Being a semi-desert country in South Africa, they do experience wildfires, and having the use of a time-lapse camera can assist. There's also many other applications that a time-lapse camera can be used for, looking at coastal erosion over time, looking at litter traps. We've also used these time-lapse cameras. We've got a forward-facing version like I've got here in my hand, and we have a downward facing version, which we've designed for the open cleanup. It is incorporated with AI technology to be able to identify litter particles floating by under a bridge. And it has multiple other applications, whether it's monitoring construction sites to monitoring estuaries, water flows, sensitive areas, canals. Yeah, having eyes or visual representation in the field is super crucial. So how does this all come together, and how does it fit in to be able to guide forecasting data and forecasting systems? All of this, all of your sensors, all of these sensors are inputted into a data portal. So on your cellular device or onto your computer, you're able to have near real-time data depending on the sampling interval that you've selected. So if you've had one of each of these devices that I've just spoken about, you will be able to view them all in one spot. Look at all of the parameters that they would measure, if it's an ADCP, if it's a water quality sonde, bulk wave parameters from a wave buoy. These would all be viewable on a data portal, and I will do a demonstration for you shortly. We can provide you with alerts and threshold alerts. So if there's something that is critical and you need to monitor the water level heights, the minute the water level is exceeded, there will be a threshold alert that will be sent to you. Up to 50 users. There's a possibility of doing remote or private servers if there's data security concerns. All of these are possible when it comes to making sure that your data is secure and your data is available. Perfect. So a case study, a physical case study in which these devices have been used and inputted into an early warning system to reduce risk and to hopefully save lives. It's happened in eThekwini in South Africa. It's a coastal province on the east coast of South Africa. A large area. It has the largest port in Africa, or in sub-Saharan Africa, and it does about 31 million tons of cargo annually with a population of 4.2 million people. One major concern is that 25% of that population they reside in informal settlements. The concern with that is that if it is not areas that have been earmarked for populations to reside, they are normally flood areas or low-lying areas. Hence, the need to have an early warning system in this area. Also, the ports there's multiple tributaries. Drainage points are normally clogged with refuse, organic matter. Having a visual representation in the field allows you to be able to have those areas cleaned using those time-lapse cameras, which I'll show you shortly how that applies in ensuring that litter traps flood thoroughfares are cleaned. Those are all crucial. However, the area does suffer from lack of maintenance. Um, Drainage points are normally clogged. And I think when it comes to doing any early warning system, it is crucial to understand the local dynamics and apply that with historical data and real-time data to be able to add to satellite forecasts and satellite weather parameters to produce. It needs to be a holistic approach. In this case, in eThekwini, the system is used to provide early warning to remote areas. So in vulnerable communities residing in low-lying areas, they are able to be evacuated and to be warned prior to these events. Having 5 minutes to be able to get people out can save a few lives. We've got here in this case, the flooding events or extreme weather events have occurred more and more recently in the last decade, having 2007 was an extreme flooding event, 2019, 2021, and 2022. So the need for monitoring and for early warning systems is becoming more and more crucial. Identifying the patterns in the hydrological flows and the meteorological changes is also super crucial. So having historical data, real-time data, allows you to input this into forecasting models. Normal weather predictions, they are seldom validated, and there's normally no consequence to that. However, in extreme weather events where people may risk or have a risk of losing their lives or their livelihoods, these forecasts have huge weight. So preventative action can be taken if the forecasting is done correctly, and having localized weather monitoring systems been proven to improve the accuracy of forecasting models by 50%. So coastal and mountainous areas or areas easily susceptible to flooding, it's crucial to have localized systems to be able to provide localized weather information. So how does an early warning system work? You have your observations, which will be provided by the devices in the field, and you have the early warning system, which will then process that information. These will talk to each other. Okay, using our data portal, there's an API directly into these early warning systems. So the data that comes from the device is instantaneously inputted into these early warning systems. They are obviously looking at the operational conditions, and we are wanting to apply action to this information, because without action, the information is useless. So we're looking at storm or weather warnings to be able to evacuate people or to move people out of areas, but we're also looking at extreme weather events. What are the high flood lines? What was the rainfall intensity during that period? Were estuaries open? Were they closed? Were they susceptible to back flooding? If there are trash traps that have been set in place, they can become a hindrance to water flow if they are not cleaned periodically. What are the beach sediment levels that will affect storm surges, coastal flooding? Now, this all gets plugged into long-term data, so we can look at historical flooding, 50-year flood lines. We can look at rainfall levels, historic rainfall. We know what to expect in the worst-case scenario. Once you have that long-term data, you can look at long-term improvements. So infrastructure redesign, city planning, capacity requirements. It always seems to be the case that in developing areas or rapidly developing areas, the infrastructure seems to lag behind the development. It's always everybody's happy to put up building and infrastructure. However, the infrastructure that gets updated last is stormwaters and other sort of complementary services. This long-term data assists in the model calibration and validation. So as we were speaking to earlier, we seldom validate or correct weather forecasts. Having the long-term data, having the real-time data allows us to correct long-term forecasts. based upon previous errors or previous adjustments. So, how does this all apply in disaster management? Do we decide to evacuate individuals? Do we know if the disaster warnings are correct or they're not? So we need some sort of ground truthing. Are the long-term satellite forecasts correct? And what are our high-risk areas? Where is the water coming from? Where was the catchment area? These all need to be measured and monitored in real time to be able to reduce the risk and reduce the harm. So some of the benefits of using the Obscape devices versus other devices for this kind of application is that areas that are remote and do not have power supply, the device will operate with no issue. Devices can be interconnected very simply and easily and loaded onto specific projects. There are no complicated integration requirements. We have to stress, especially for forecasting and early warning systems and validation, localized data is crucial. You cannot just rely on satellite forecasts. The data is very easily sent via API or a private server to the early warning services. That's the systems that need the data. That data is readily available all the time. Having satellite or cellular communication as backup, cellular communication is the devices can work in a hybrid fashion. So while there's cellular data, the device will run on cellular. If there's no cellular connectivity, the device will automatically switch to satellite. So you shouldn't have any interruption in your data transmissions. Just to summarize sort of the products that we currently have and how they all interlink and how they can provide a holistic review of the environment for early warning systems, from water quality to storm surge, visual aids, to conductivity and temperature sensors that are used in estuarine applications. I am going to do an Obscape demo. I don't know if there are any questions at the moment, Andrea.
I do not see any in chat yet, Jason.